I'd like to echo the comments of Joachim and Mark, and thanking you all for being here for this presentation. I intend to take about 20 minutes, and then we'll turn the floor over to David Waskow for some comments. Let me start, first of all, with some acknowledgments. This work isn't done by a single person or even a couple of people. There's a large team involved. These are the authors of the report, on the report. Are those of you in the room, please stand up and wave your hands. I see some of you in the back and other places. I should add, although their names are not on the report, the communication staff, the editorial staff at this institution are incredible and make this kind of a publication that has both good content and good outreach possible. I should also thank a couple of other groups. Ken Stressbeck and Adam Schloss are responsible for downscaling the climate scenarios that we use. We're not yet to the point where we manipulate those giant GCMs, although I have ambitions. The World Bank and the Asian Development Bank both funded the research that we did. The World Bank work was part of a larger study looking at, across all sectors of the economy, the cost of adaptation to climate change. And we'd like to thank both staff from both of those studies for their valuable comments and insights on this report. Let me start with a preview of the results that we have. Unchecked, climate change will result in a 20% increase in malnourished children by 2050. That's about 25 million additional children in a world that has climate change as compared to a world that doesn't have climate change. In order to compensate for that increased number of children, in other words, to reduce the number back to the level that we would have without climate change, we estimate the need for annual expenditures of at least $7 billion. We actually are conservative in our numbers. We've tried to be conservative in our modeling of the effects of climate change on agriculture. Brief outline of the talk. We're going to talk about our climate change modeling methodology, the fact that we incorporate both biological and socioeconomic effects. Then we'll take a look at how those various modeling techniques lead to impacts, looking, for example, at straight biological effects on crop yields, but then translating those through the marketplace to get effects on prices, production, and international trade flows. And then the issue, which is really in some sense a fundamental concern, which is the availability of calories to people and the consequent outcomes for child malnutrition. Once we have some estimates of child malnutrition, that allows us then to say what would it take in terms of expenditures on agricultural productivity to make more food available to reduce the number of malnourished children. We end with some policy and conclusions. So first of all, the modeling methodology. One of the things about agriculture that those of you who have been here before have heard me say, it's intensely location specific. So, location is really important for agriculture. But it's also important to understand that it's not just biological productivity effects, it's how human beings respond to those changes. So it's important to combine biological and socioeconomic modeling. So climate change brings location-specific changes in temperature and precipitation and variability in those things to the local agronomic, in other words, soil conditions in particular, and market conditions that farmers face every day. The modeling challenge that we face was to take those fairly detailed micro-level biological effects and incorporate them into an economic model which, while it is the most disaggregated that exists in the world, it's still fairly aggregated. And the result, well, we hope at least, is more realistic modeling of climate change effects on combining the biological and the economic on global and regional agriculture. So let's start with this, some of the details. One of the things that we do differently, and this is the part of the work that the World Bank did, was to look at two different GCMs. We chose these GCMs because one of them is wetter in 2050 in the sense of more precipitation on land than the other. Anytime you have higher temperatures, you get more evaporation, water goes up into the sky, it's got to come down someplace. If it comes down on land, you end up with more precipitation. And these are the outcomes that we have for these two scenarios. We use the DSAT crop model to estimate the biological effects. We use the ISPAM data. This is a data set that IFPRI has developed to show where on the surface of the planet to estimate those effects. And then we use the impact model, the 2009 version, then to take the biological impacts from both the crop and the hydrology modeling incorporated into the detailed economic model. So let's start with some facts. So here's some facts. This is what we already have seen happen to temperature between 1880 or thereabouts in 2000, about a degree increase, Celsius degree increase in temperature. And the temperature could increase substantially more depending upon which of the IPCC stress scenarios you believe is correct. I've circled the A2 scenario. That's the one we use. That's the bright red line that looks to be fairly extreme. But if you look at actual emissions of CO2 and the equivalents to date and compare them with the A2 scenario, so the A2 scenario here is the light blue line. Watch what happens to actual emissions for the years for which we have data. They are substantially higher than estimates for the A2 and substantially higher than sort of, not estimates, but scenario predictions for all of the stress scenarios. 2.3% was the A2, 2.13% was the A2 average. We actually see 3.5. So while the A2 scenario at one point was sort of thought to be a relatively extreme, as in high temperature scenario, it may in fact be moderate relative to where we could be heading. So more water up, more water comes down, but where it comes down depends upon the model that you look at. I'm going to show you two different comparisons here. So this is changes in precipitation for the CSIRO model. Look at your favorite part of the world. If you're interested in biodiversity effects, take a look at the Brazilian Amazon. If you're interested in poverty, take a look at sub-Saharan Africa or India. Notice the bright reds are places where precipitation will be lower than it is in 2000. The greens and the blues is where precipitation will be higher. In the Amazon, it's to the west. In sub-Saharan Africa, a big chunk of red. In the southern part of sub-Saharan Africa, India looks like, in South Asia, the Bangladesh region has declines in yields. Compare that now to the NCAR, where first of all there's just a lot more blues and greens, higher precipitation generally, but the precipitation changes in the Amazon shift from being lower in the west to lower in the east. Sub-Saharan Africa is not nearly as bad off, at least in terms of the color red, and the same thing can be said for India. This indicates some of the uncertainties that exist in the spatial distribution of the effects of climate change. All of the models have higher temperature, but where the consequences of those higher temperatures result in effects on agriculture depends on the scenarios that you look at. Here's just a selection of some of the biological yield effects that we come up with. I would say rather than study the individual numbers, just notice that for the most part they're all red, negative yield effects, looking at irrigated rice, rain-fed maize, and rain-fed wheat. But in a couple of cases, one scenario, we find that there's actually a slight increase in yields. For example, the East Asian and Pacific NCAR yields are 1.5% increase. But that's in a, if you will, a sea of red. Those averages, however, conceal great variation. Now what I want you to do as I bounce through some slides looking at yield effects is to look for the colors. Again, yellow and red are bad, light blue and dark blue are good. First of all, irrigated rice. Lots of yellows and reds in South Asia. In China, mixed green and yellow, or mixed blue and yellow. Southeast Asia, mostly yellow. That's NCAR. With CSIRO, the location changes and the mix of yellows and blues changes. If we look now at rain-fed rice, we see a slightly different picture. Here, rain-fed rice is not grown. Most of the rice grown in China is actually irrigated. But again, we see that there are substantial changes between the two scenarios about where the negative effects are located. And let me finally end with rain-fed maize. And I ask you now to look at the United States, since we happen to be located in Washington, D.C., and look what happens to the Corn Belt between the two scenarios. We're actually going to explore the Corn Belt a little bit further in some additional research that we're doing to understand how the different scenarios, what they have to say about changes in yields in the Corn Belt. So that's the biological side of the story. Now let's walk through briefly the effects on the of those biological changes, for the most part negative, on prices production, and malnutrition. So here you have the basic results on prices. World prices are a good single number to take a look at the effects of climate change. The first point to note is, unlike IFPRI estimates of 5 to 10 years ago, which showed continuing price declines, even without price declines today, we see, even without climate change, we see price increases between now and 2050 for all of the major crops. This is a consequence of higher population, and higher population that's going to have, we hope, higher incomes, and so therefore demanding more food. Food security issues, even without climate change, are critical. But add climate change on top of the story, and you see that we get even greater price increases across all of the major commodities. The results in this case are broadly similar between the two scenarios. What about production? I'll give you a few production slides. Here's rice. One thing you might note, while production effects from the no climate change to the climate change outcome are negative, that is, production goes down, you should note also that the rice in East Asia and the Pacific effects are negative between 2000 and 2050. This is actually a good thing. This is the change in Chinese consumption from rice to other various commodities that they're diversifying their diet. But the production effects from climate change then push those rice production numbers down and down everywhere in the world relative to the no climate change situation. Wheat production, we have large production increases in some regions of the world without climate change. Climate change pushes those numbers back down to what they are in 2000. If you look at maize production, you see that without climate change, there are substantial increases in production numbers in all of the regions that are important maize producers. Climate change has mixed effects on the production relative to the no climate change scenario. And then finally, let me say something about trade flows. Let me focus your attention on a couple of different things. The first of all is that trade is a potential equilibrator and helps to accommodate for climate change effects. So you'll see that for some parts of the world, trade flows actually change direction depending upon the nature of the climate change that is coming. With the CSIRO results, we end up with more exports from developing countries, substantially more exports from developing countries, and therefore more imports into developing countries. Now, I emphasize this not because that particular result is so important, but to highlight that trade flows depend on which of the climate change scenarios you look at. And now the child malnutrition numbers. So the good news is that the world was on a good path. With the exception of sub-Saharan Africa, child malnutrition would fall in all parts of the world. And even in sub-Saharan Africa, the relative numbers go down, but because of large population increases, there's a slight increase in the absolute number of malnourished children between 2000 and 2050. These are without climate change results. With climate change, child malnutrition increases everywhere in the world. So what can we do about it? One of the interesting issues that we had to deal with when we were doing these studies is, what do you mean by adaptation expenditures? What is it that agriculture should adapt to? I mean, should we try to get back to the production levels that would exist without climate change everywhere? Should we have equal trade flows? The choice we made was to focus on the direct human well-being measure, and the one that we can do some empirical estimates on is the one that looks at child malnutrition. So we asked the question, what does it take in terms of agricultural investments to reduce child malnutrition with climate change to the numbers without climate change? What types of investments do we consider? Agricultural research, irrigation expansion and efficiency improvements, and rural roads. So the bottom line, which you have already heard, is that adaptation costs are over $7 billion. They differ slightly depending upon the scenario that you choose, $7.1 billion for the NCAR and $7.3 billion for the CSIRO. The regional expenditures vary. Sub-Saharan Africa is about 40% of the total at $3 billion. Most of those expenditures are actually for rural roads because rural road density in Sub-Saharan Africa is much lower than it is in other parts of the world. South Asia, $1.5 billion with an emphasis on research and on irrigation efficiency. Latin America and the Caribbean is $1.2 billion a year, focused mainly on research, but road expenditures as well. East Asia and the Pacific, $1 billion a year for research and irrigation efficiency. I would like to emphasize at this point that why these numbers are considered an underestimate. There are many places that we are not able to adequately, to our satisfaction, quantify the effects of climate change. What are those? First of all, we don't take into account the variability, increased variability that one expects to see with climate change, which will have an added negative effect on agricultural productivity. We don't take into account the fact that the glaciers are likely to melt in the Himalayas and reduce stream flows in some important rivers in South Asia, which may very well turn some of those irrigated areas into rain-fed areas for part of the year at least. We don't take into account the fact that pests, both insect and disease pests, are likely to become more virulent with climate change, and therefore our productivity effects are overestimated. And the fourth thing that we don't take into account is the fact that sea level rise could have some very dramatic negative effects on low-lying rice production areas, in particular in the Mekong Delta, in Egypt, in Bangladesh. So for all these reasons, we think that these are likely to be underestimates of the actual adaptation costs. Conclusions. Climate change will have negative effects on agriculture. These are lower yields, higher prices, more malnourished children. One of the sort of cup half full points to come out of this is that changes in trade flows actually reduce the strict negative the negative effects strictly from the biological side of the story. Agriculture is critical for poverty reduction. Today, most of the poor people in the world are intimately engaged in the agricultural activities in the developing countries. That is where we need to focus our efforts if we're going to deal with poverty reduction. But agriculture is also important for general economic development, and of course, not last, but certainly not least, food security. These large additional expenditures should start now to reduce the adverse effects of climate change. What do we recommend? Perhaps the most important key recommendation for today: start with good overall development policies and programs. Anything that you do to raise the income of poor people makes them more resilient to change, whatever that change is that they're going to have to face. Recognize that the food security debate and the climate change debate are really the same debate. Anything that you do for food security, you also do for climate change adaptation. And anything that you do intelligently for climate change adaptation, you also do to increase, to enhance food security. $7 billion is the bottom of the estimates, what we think is needed for adaptation. And of course, it doesn't factor in at all the costs that we need to deal with the growing number of people in the world who will have higher incomes. Those are additional expenditures beyond what you need just for climate change. Think locally, think globally, and act in both dimensions. Global public goods are needed. We really need much better global data collection, dissemination, and analysis. Within the negotiations that are heading towards some kind of a conclusion in December, we need to ensure that agricultural adaptation is a key agenda point. Joachim mentioned that that's certainly on the table and it wasn't before, but we can't stop emphasizing that point now. Agricultural trade is also important. In completing the Doha round to make trade flows work more smoothly is essential in helping countries to adapt to coming climate change. And of course, agricultural productivity research at the global level is necessary because there are many synergies that exist between work that's done internationally with the outcomes locally. But there are national public goods that are needed as well. We being the human species, have disinvested in national research and extension systems around the world, and we need to change that. You also need to build a supporting national infrastructure, both the physical infrastructure and the institutional infrastructure. So we need to provide a supportive policy environment. We also need to recognize that agriculture is done on the farm by individuals who live in communities. We need to make sure that they both are part of the solution, but also help us to come up with the answers. Why should we do this? The activities that we've proposed in this report are activities that are, in some sense, the minimum that are needed to deal with the problems of malnutrition. Business as usual cannot continue if we are to have our children and our grandchildren live the lives that we would like them to live. So thank you very much.